Hello student, I am Mrs. Shweta Shailendra Pandare, Assistant Teacher, Vidyapit High School, Kolhapur. Chapter 3, Chemical Reactions and Equations. At last, we are seeing steps in balancing a chemical reaction. Now we are learning types of chemical reactions. Chemical reactions are classified into four types, that are occurrence with the nature and the number of the reactants and products that are present in the reaction. First type, combination reaction. Second type, decomposition reaction. Third type, single displacement reaction. Fourth type, double displacement reaction. First, combination reaction. See definition: when two or more reactants combine in a reaction to form a single product is called a combination reaction. Activity first. Take a small amount of hydrochloric acid in test tube or beaker. Heat the test tube. Then dip a glass rod in a ammonia solution, that is ammonia solution, and hold on top of test tube or top of beaker. You will observe white color smoke emanating from the tip of glass rod. What must happen? Due to heating HCl, vapor starting coming out from the test tube and NH3, that is the ammonia gas, come out from solution of glass rod. Here the HCl heating, so vapors are coming out of this, and also this is the glass rod that dip in the ammonia solution, and ammonia gas is coming from this glass rod. Hence, let's see the reaction. Ammonia gas and hydrogen chloride react from form a ammonium chloride in gaseous state first, but immediately due to condensation process at room temperature it got transformed into solid state. As a result, white smoke was formed. The chemical equation, that is here NH3, that is ammonia, plus hydrogen chloride HCl gives to NH4Cl, that is ammonium chloride. So this is equation number 12. Activity 2. Hold a magnesium strip in pair tongs and ignite. On burner in air, a white powder of magnesium oxide is formed. In reaction, twice Mg plus O2 when react, formation of twice MgO, that is magnesium oxide. This is equation number 13. In this reaction, magnesium oxide is formed as a single product by combination of magnesium and oxygen. So this is a single product in this reaction. Activity number 3. Take water in a beaker half of its capacity. Add few pieces of slacked lime, that is calcium oxide, In it, there is formation of calcium hydroxide. By combination of the calcium oxide and water, there is generation of large amount of heat. Here in this reaction, let's see the reaction. CaO, calcium oxide, plus H2O, water, gives to formation of calcium hydroxide, and also large amount of heat is from this reaction. This is equation number 14. In combination reaction, two or more reactant combine to form a single product. In all these three examples, there are two reactants. When react with each other, there is formation of a single product. Hence, this reaction is called combination reaction. Second type of reaction, decomposition reaction. Definition: the chemical reaction in which two or more products are formed from single reactant is called decomposition reaction. Try this first. Take some sugar in an evaporating dish. Heat with help of burner. After some time, you will see formation of a burnt out black substance. In above activity, a single reactant is divided, that single reactant sugar is divided into two substances, that is carbon and water. The reaction in which there is only one reactant gives rise to two or more products is called decomposition reaction. And this is equation number 15. Try these two. In this, take some calcium carbonate in test tube. Fit a bent tube to this test tube with the help of rubber cork. Insert the other end of this bent tube in the test tube that having freshly prepared lime water. Then the powdered calcium carbonate heat strongly. What happened in this reaction? Calcium carbonate undergoes decomposition reaction and there is formation of carbon dioxide gas. Hence, this lime water turns milky. Let us see the equation. Calcium carbonate, that is CaCO3, when undergoes decomposition, there is formation of calcium oxide CaO plus carbon dioxide gas is evolved. This is equation number 16. Then next example, hydrogen peroxide naturally undergoes slow decomposition. Hence H2O2 when decomposed gives to water, that is H2O, and oxygen gas is evolved. So this is equation number 17. Equation number 16 and 17 are also the examples of decomposition reaction. Third type of reaction, displacement reaction. The reaction in which the place of ion of a less reactive element in a compound is taken by another more reactive element by formation of its own ions is called displacement reaction. Third displacement reaction, we saw in the beginning of the chapter that CuSO4, that is blue colored solution, when added into the zinc dust, there is formation of colorless, that zinc sulfate solution, and heat is get evolved or generated. Let's see the equation number 3. CuSO4 plus Zn, that gives ZnSO4 plus Cu. In this, that Zn2 plus ions formed from zinc atom take the place of Cu2 plus ions in copper sulfate, and Cu atom from Cu plus 2 plus ion come out. It means that zinc displace Cu from CuSO4 solution, and here formation of that zinc sulfate and Cu is get displaced. In the second example, when iron nail is kept in blue colored copper sulfate solution, that ion formed from iron atom take place of Cu2 plus ions in CuSO4 solution, and copper atom formed from Cu2 plus ions come out. That is, more reactive iron displace the less reactive Cu from copper sulfate solution. Hence, here is the color of solution is get changed, that is greenish color solution, and Cu is deposited on the nail. Hence, you complete these two reactions. Then last reaction, there is CuSO4 solution plus Pb. So Pb displace Cu, then formation of which products, here you write in your notebook. Fourth type, double displacement reaction. Definition: the reaction in which the ion in the reactants are exchanged to form a precipitate are called double displacement reaction. Double displacement reaction, we have seen in the equation number 9 that white precipitate of silver chloride is formed by an exchange of silver and sodium ions present in reactants. Let's see the reaction. AgNO3 silver nitrate plus NaCl sodium chloride gives to AgCl silver chloride, that is white color precipitate, plus NaNO3 sodium nitrate. White precipitate of AgCl is formed by exchange of ions, that is exchange of Ag and Na, white color precipitate of AgCl. In second example, that barium sulfate BaSO4 react with K2CrO4, that is potassium chromate, there is formation of yellow color PPT, that is of BaCrO4. These are the examples of double displacement reaction. Next to that, endothermic and exothermic processes. and reactions. First, exothermic process. Definition: the process in which heat is given out are called exothermic processes. Second, endothermic process. The process in which heat is absorbed from outside is called endothermic process. Endothermic reaction versus exothermic reaction. Let's see. First, exothermic reaction, a reaction that releases energy to surroundings, causing the reaction mixture and its surroundings hotter, that called exothermic reaction. Here heat is given out. Example: NaOH, sodium hydroxide plus H2O, that is solution of or aqueous solution of NaOH, that is the example of exothermic reaction. So this reaction, the mixture and surrounding become hotter. Next, endothermic reaction, a reaction in which energy is absorbed from surroundings, causing the reaction mixture and its surroundings to become cooler. In this reaction, the energy from the surroundings is absorbed in this the solution. For example, KNO3, that is the potassium nitrate plus H2O, solution of this potassium nitrate. Thus in this reaction heat is absorbed, hence this solution is and surroundings become cooler. Next examples, that CaCO3 plus heat gives to CaO plus CO2 gas evolved. That is the example of endothermic reaction. Here heat is absorbed. Next, CaO plus H2O gives to CaOH twice plus heat. Here heat is given out. So these are the examples of endothermic and exothermic reaction and also the difference in between them. In this video, we are study about types of chemical reactions. First, combination reaction. Second, decomposition reaction. Third, displacement reaction. Fourth, double displacement reaction. And endothermic and exothermic processes.